Chapter 6 is titled The Language of Chemistry. And this chapter has to do with naming compounds and writing formulas for compound. It's also called nomenclature. Nomenclature is a system of naming. So IUPAC nomenclature is the official international system for naming chemical compounds. IUPAC stands for International Union of Pure and Applied Chemistry. And so people from all different nations got together and decided, let's have a system that everybody's going to use, because until then, whoever discovered something just gave it whatever name they wanted to. And there were very little patterns in how things were named, and so it got really confusing. It's like someone having multiple nicknames, right? And this group of people knows him as Tommy, and these guys know him as Flash, and somebody else knows him as Tiger or something. And then you start talking about this person, everybody knows him by a different name, it gets really confusing. So this is a subject that students tend to have some difficulty with. But if you'll bear with me, I'm hoping I can show you that it's really not that bad. There are different systems of naming. There's a different set of rules for different kinds of compounds. So we're just going to learn about inorganic compounds and acids. These are divided into 5 categories. There's a different way of naming things for each of the 5 categories. And they didn't do that just to be difficult, but because it's just not appropriate to name all compounds in the same way. And this is not unlike the different systems of naming that people have for their children in different countries. My ancestors came from Sweden. They don't do this anymore, but it used to be that the children took the father's name as their last name. So if you were a girl and your father's name was John, your last name would be Johnsdotter. And if you were a boy, a son, and your father's name was John, your last name would be Johnson. Well, if you were Peter Johnson and you had a son, Olaf, he would be Olaf Peterson. So it was kind of nice because it let people know who your dad was, but it's confusing because each generation then the last names changed, right? They don't do that anymore. In this country, traditionally, the children take the name of the father, the last name. So it's a different system. And we're okay with stuff like that. When we talk about different rules of naming for compounds, we get all crazy. So we just have to figure out what country are these compounds for so that we can use the right name. So identifying the category that the compound you're trying to name is in is critical for naming the compounds. So these are the categories. And inorganic compounds, what do we mean by that? Well, these are compounds that do not contain carbon. There's a couple of exceptions. Carbon dioxide and compounds with carbonate ion in them are considered inorganic. But otherwise, everything else with carbon in it is considered to be an organic compound. And that is a completely different course where you learn how to name those. So we're not going to do those at all. We're just going to stick to the inorganic. There are ionic compounds. Ionic compounds have ions in them. There's 2 groups of ionic compounds, binary and ternary. Binary means 2. A binary ionic compound has 2 elements. Let me get out my highlighter here. But yellow's boring, so let's maybe use blue. So binary, oh, that's not blue. Oh, well. Binary, 2 elements. There has to be a metal and a nonmetal. We just learned about ions, that metals form positive ions and nonmetals form negative ions. Opposite charges attract each other. So if you have a nonmetal ion and a metal ion, their charges are opposite and they will stick together and form a compound. You can't form a compound out of 2 metals. They both have positive charges and they will repel each other. You could try to stick them together, but it's like putting the wrong ends of 2 magnets together. You can push them together, but they won't stay. If you turn the magnet around and use the South Pole to the North Pole, they'll stick all by themselves. It's like magic. The charges on ions are like magnets. Electrical fields are much like magnetic fields. So for the binary ionic compound, the key is there are two elements. One's a metal, one's a nonmetal. The other type of ionic compound is called ternary. Ternary means three. So these compounds have three elements, at least one metal and one nonmetal. You could have two metals and one nonmetal, or one metal and two nonmetals, but you have to have at least one of each. Okay, that's a ternary ionic compound. Then we have molecular compounds. The molecular compounds we're going to learn to name are called binary molecular compounds. Again, that word binary, two. These guys have two elements, and they are nonmetal. Two nonmetal elements. That's how we identify binary molecular compounds. And then there are the aqueous acids. The aqueous acids are in two groups, again, binary and ternary. Binary acid is an aqueous solution containing hydrogen and one other nonmetal. So again, we have the two elements. But here we're specifying that one of them has to be hydrogen. So hydrogen and one other nonmetal. That word aqueous, an aqueous solution. An aqueous solution means that the acid is dissolved in water. So it's dissolved in water. And another thing that's helpful is to note that the formulas for acids always begin with H. So if we're looking at formulas and we're trying to identify what category is this in, if it starts with H, it's an acid. And the names are nice too because they actually have the word acid in the name. But a binary acid is hydrogen and one other. Ternary acid, guess what? It's got three elements in it. This is a ternary oxyacid. So it's got oxygen. So it's got hydrogen, a nonmetal, and oxygen. So that's how we identify a ternary oxyacid. So here's a flow chart from your book showing this organization. Inorganic compounds and acids. This is the group of chemicals that we're going to learn how to name. It's divided into ionic, molecular, and aqueous acids. Molecular compounds do not have ions in them. Ionic compounds do. Ionic compounds are broken down into binary containing two and ternary containing three elements. At least one has to be a metal and one a nonmetal. Molecular, we're going to be talking about the binary molecular compounds, two nonmetals. Aqueous acids, binary acids, hydrogen and one nonmetal. Ternary acid, hydrogen, oxygen, and one nonmetal. So let's practice classifying. Classify each of the following as a binary ionic compound, a ternary ionic compound, a binary molecular compound, a binary acid, or a ternary acid. So those are all 5 categories. Let's look at this first one, carbon disulphide. Well, the name might not mean that much to you. That's why I gave you the formula as well. How many elements are in this? 2. One way we can tell is by looking at capital letters. Because like this one has a lot of letters in it, right? Each element has one capital. So if you count the number of different capital letters, that tells you how many elements. So this has 2 elements. So it's going to be binary something, right? Are these, this is carbon and sulfur, are those metals or nonmetals? They're both nonmetals. So 2 nonmetals means it's what kind of a compound? Binary molecular. So I'll call that BM, maybe BMC, binary molecular compound. I have young children, and so they think BM is funny. Lithium dichromate. We've got how many elements? 3. Lithium, chromium, and oxygen. So are any of these metals? Yes. And oxygen is a nonmetal, right? So three elements, it would be ternary something. Ternary ionic compound or ternary oxyacid. Well, does it have hydrogen in it? No, it doesn't. So we're looking at a ternary ionic compound. Or I guess that's a tick. Magnesium iodide. How many elements? 2. Is the first one a metal or a nonmetal? It's a metal. So what kind of a compound is this? Binary ionic compound. Because the binary molecular is 2 nonmetals. The ionic has a metal in it. How about this one? The name is nitric acid, and here's the formula. It's a ternary oxyacid. So we're looking at it, the AQ means aqueous, that's kind of a giveaway. The name acid is a little bit of a giveaway too, isn't it? 3 elements, H, N, and O. We have hydrogen and oxygen and 1 other nonmetal. And that's what a ternary oxyacid has. How about this one, hydrochloric acid? It's got 2 elements, so it's a binary acid. It's got hydrogen and a nonmetal, and it's an aqueous solution. Any questions? Does that make sense? You have to be able to do something like this to be able to successfully name the compounds. Because this is the first step. You look at the compound and you figure out what kind of a compound is this. It's like, let's talk about, 300 years ago or something. My husband came from Japan. Well, his ancestors came from Japan. My ancestors came from Sweden. Well, if you're looking at 300 years ago naming children and you're trying to figure out how this child is named, it would help to know what country they're from and what system that culture uses for naming their children, right? It's the same idea with the compounds. We have to identify what kind is it so we can apply the correct rules for naming it. So that was classifying the compounds themselves. We also have to look at the individual ions, and we kind of threw these words at you in the last chapter and really didn't say what they were. Positive ions. Which forms positive ions, metals or nonmetals? Nonmetals form negative ions. Non-metal negative. So metals form positive ions. Positive ions are called cations. And this is a word that you need to remember, and you need to remember that cations are positive. So if you like cats, then this will work for you. I personally like cats. We currently have 2, although they drive me bananas sometimes. But cat, positive. I have positive feelings for cats. Cations are positive. If you don't like cats, well, I guess that won't work. That might work. Cation has a T in it for positive. I like that. Oops. So Ca plus ION. That works. Negative ions are anions. Anion does have an extra N in it, which may help you. Anions are negative. Okay? And it's cation, not cation, like vacation. And this is anion, not a misspelled onion. It's not anion, okay? Anion. So anions and cations, positive and negative. Anions are negative, cations are positive. And then we also think about ions in terms of how many atoms are in that. So monoatomic means 1 atom. These are single atoms. They can either have a positive or a negative charge. The charge is what makes it an ion. If it has no charge, it's an atom. Polyatomic, poly is a prefix that means many atoms. So these are groups of atoms. They're bound together, they're stuck together, and together they have overall a positive or a negative charge. So just some examples, perhaps. If we look at magnesium 2+, is that monatomic or polyatomic? How many elements are there? How many atoms are there? 1. It's monatomic. If we look at something like NO3-, you see there's one atom of nitrogen and 3 of oxygen. There's multiple atoms, so this is polyatomic. What about that one? Monatomic or polyatomic? This one's monatomic. And how about that guy? Polyatomic. So ions can be positive, cations, or negative. And within each of these, positive or negative, you have monoatomic, one atom, or many atoms. You can have anions that are one or many. Examples. Classify each of the following ions as a monatomic cation, a monatomic anion, a polyatomic cation, or a polyatomic anion. Hydronium atom H3O+. Polyatomic cation. It's got a positive charge, so it's a cation, and there's more than one atom in there, so polyatomic cation. How about sulfide ion? Oops. Sorry. My superscript fell down. I fixed it. Sulfide, S2-. Monatomic anion, right? So I lost this one. This was a polyatomic cation. Monatomic anion. How about permanganate ion, MnO4-. Polyatomic anion. And SN2+? Yep, monoatomic cation. So that's not too hard, is it? Mono, one, poly, more than one. Which reminds me of when my second child was like 2 or so, and he, it's so funny how kids learn about the world around them, and they learn to count and stuff. And for a while, he had 2 numbers, 1 and 2. 1 meant 1, and 2 meant anything that was more than 1, right? So that's like this. Mono is 1, and poly is everything more than 1.